This is looking at the difference between heat and temperature. Temperature describes how hot or cold an object is, which is determined by how fast the average kinetic energy of the individual particles that are in motion. So remember, the kinetic energy is moving energy, so how fast those particles are moving. The warmer the temperature is, means that the particles are moving fast and have more energy. If something is cooler, then those molecules are moving slower and have less energy. We measure temperature with a thermometer. Now, there are 3 different temperature scales that are obviously the most common that we are most familiar with is Fahrenheit. It's part of the English system and not common worldwide. Celsius is the most common. It's our SI unit that we'll be using, especially for lab, and Kelvin is also common around the world. When we look at the Kelvin scale, the coldest unit on the Kelvin scale is 0 Kelvin, which is also called absolute zero. And that means at 0 Kelvin that there is no zero or no motion. So there is 0 kinetic energy. Those particles are literally frozen, which is not going to happen. Particles have always had just the smallest bit of energy. So you can see here that this first one is our Fahrenheit scale. So we know that water freezes at 32 degrees Fahrenheit, which is equivalent to 0 degrees Celsius and 273 K. Water boils at 212 Fahrenheit, again, which is equivalent to 100 degrees Celsius and 373 Kelvin. So how do we get from one scale to the next? When I want to find Celsius, if I have Fahrenheit, I just simply take my Fahrenheit temperature, subtract 32, and divide it by 1.8. That would get me to my Celsius. If I have Celsius and need to get to Fahrenheit, I need to take my Celsius temperature, times it by 1.8, and then add 32. To get to my Kelvin scale, I would just simply take my Celsius temperature and add 273. 1 degree change in Celsius is equal to 1 degree change in Kelvin. So those scales have similar increments. The Celsius and Fahrenheit do not. They're 1.8 difference. So let's convert the freezing and boiling temperatures for all 3 scales. Yes, we know that freezing is 0 degrees Celsius and that freezing is 32 degrees Fahrenheit. We know that just from memory, but if let's plug it into our system up here just to verify that we can work it out. So if I said my Fahrenheit, 32 degrees Fahrenheit minus 32 divided by 1.8 will give me my Celsius. Well, we know that 32 minus 32 is 0. So that's going to give me my 0 degrees Celsius, which is great. That's what I want. And then I can also say, well, my 0 degrees Celsius times 1.8 is obviously 0 plus 32 will give me my 32 Fahrenheit. Okay, now let's try, I'm going to erase this, and let's go the boiling. Let's say that my boiling is 212 degrees Fahrenheit. minus 32 divided by 1.8. So 212 minus 32 is 180, and 180 divided by 1.8 would give me 100 degrees Celsius. And the other way around, if I took 100 degrees Celsius times it by 1.8, would give me 180, and then add 32, so 180 plus 32 would give me 212 Fahrenheit. Now, if I wanted to figure out what boiling was in Kelvin, I need to take my Celsius temperature and add 273. Not my Fahrenheit, but my Celsius. So 100 plus 273 is 373 K. Great. Now, liquid nitrogen, which is super fun to use, is used by dermatologists to freeze skin tissue. It is negative 193 K. What is this in Fahrenheit and in Kelvin? So let's take a second and pause the video and try setting that up. First thing that I'm going to do, since I'm given Celsius, is I'm going to go right to Kelvin, because we know that we would take our Celsius temperature, 196 degrees Celsius, plus 273 is 77 K. Circle that answer. And then I'm going to go to Fahrenheit by taking negative 196 degrees Celsius times 1.8. I'm going to do that first before I add 32. So negative 196 times 1.8 plus 32. Should get negative 320.8 degrees Fahrenheit. And I want to make sure that I have three significant figures. So negative 321 degrees Fahrenheit. Try this one. Body temperature. If you were to stick a thermometer in your mouth, 98.6 degrees Fahrenheit. What is that body temperature in Celsius, and what is it in Kelvin? So again, refer back to my Fahrenheit. Oops. To get to Celsius, minus 32, and then divided by 1.8. And we should get with three significant figures, 37.0 degrees Celsius. And to change that to Kelvin, again, we're going to take 37.0 degrees Celsius plus 273 to get 310 Kelvin. Okay, one more. Let's say that you travel to Europe and you come down with an illness. You only have a thermometer with Celsius measurements, and you are 40 degrees Celsius. You want to convert this measurement to Fahrenheit because you're most comfortable with Fahrenheit. So we're going to refer back to our equation here. Celsius times 1.8 plus 32 times 1.8 plus 32. And so 40 times 1.8 to get 72 plus 32, you have a temperature of 104 degrees Fahrenheit, which is not a good temperature since 98.6 is normal. Now, temperature is that immediate measurement. Heat is energy. Moving particles have energy, and we know that more heat means particles move faster and they're transferred by collisions. Heat is the flow of energy from an object that has a higher temperature to an object with a lower temperature. Think about holding an ice cube. If you're holding an ice cube, your body, which is 98.6 degrees Fahrenheit, right, is warmer than that ice cube, which is freezing. So what happens? The heat from our hand makes that ice cube melt. So heat is leaving our hand to go to the ice cube. The ice cube is absorbing that heat. Those particles start moving faster and go from a solid state to a liquid. So heat energy is expressed in joules or little calories. The amount of heat necessary to raise 1 gram of water by 1 degree Celsius is how heat is expressed. Now, there is a nutritional calorie, which is with a capital C, to distinguish it from the metric calorie, which is a little c. And 1 nutritional calorie is equal to a kilocalorie, or 1,000 calories. And then add this to our conversion factors. 1 calorie is equal to 4.184 joules. Remember, or we can write the reciprocal of this. So I have 4.184 joules for every 1 little calorie. We'll use that here coming up. So looking at the difference between heat and temperature. So let's say we have these 2 beakers of boiling water. We can see that they are both at 100 degrees Celsius, so they have the same temperature. We have boiling water. Here I have 500 milliliters of water, so I have a cup of boiling water, and over here I have 1,000 milliliters of boiling water. I have a pot of water. What would you rather have spilled on you? Obviously, the beaker on the right has twice the amount of heat because it has more water. There are more particles that are moving with that energy. So, yes, they are both the same temperature, but this beaker has twice the amount of energy because there's just more water. So let's look at converting from calories to joules to figure out how much heat, how much energy. We know that our food has energy in it. How much energy do these Cheerios have? So we can see from the nutritional label that this is capital C. So we're going to write on here, let's use the one with milk because who eats dry Cheerios? So we're going to write next to this that capital C is equal to kilocalories, just so we're using that for our reference. Now, if I have 150 kilocalories, and I want to figure out how many joules is in 1 serving of Cheerios. So we need to go from kilocalories to little calories. And we know, so what do I want? I want little cals, and I've got kilocals. And we know that for every 1 kilocal is 1,000 calories. So let's do that conversion first. So I've got 150,000 little calories. Now to get to joules, remember that conversion factor I just showed you back here. We said 1 calorie is equal to 4.184 joules. So since I have calories, I need calories in my denominator and joules up above. And we said 1 calorie was 4.184 joules. Again, make sure that our calories and calories are diagonal from one another to cancel out. That's the conversion factor that we need. So we're going to take my 150,000 times 4.184 to get 627,600 joules. And let's see, is this our final answer? We started with 150 as our calorie serving. So we're going to call that two significant figures. So we're going to say 1, 2. That 7 is going to make that a 3. So 630,000 joules of heat in that one serving of Cheerios.